Hello guys. No one showed. I waited half an hour and no one showed up to the live. So now this is not live. I am recording this in a different program. One that allows me to do my webcam at the same time as the screen. So I'm still going to go through the lesson, but just going to be a little different. There will be no pauses for questions because there will be no questions because there's nobody live. So today I said I was going to talk about the power of a product rule. I do have videos that talk about all of the rules for exponents or the properties of exponents, whatever you want to say. I wanted to focus on the power of product rule just so that way if you need additional examples of it, you have something that be like, I don't understand this rule, you can go to these videos. So that's sort of the plan. I have tons of examples. So I do have a list here of all of the rules that we learned this week. We've got the multiplication property, basically what happens when you multiply exponential expressions and you add the exponents. When you divide them, you subtract the exponents, top minus bottom. The power rule basically means what happens if you have an exponent and then another exponent. You multiply those together. Power of a product basically is what I call distributing the exponent. Basically, the exponent on the outside of the parentheses then gets put on the inside of the parentheses. So everything on the inside gets that exponent. So it's similar to the distributive property, so that's why I say we distribute the exponent. Power of a product, then, wait, I just did that one. Power of a quotient is where you are basically distributing the exponent to what's inside when there's a fraction. So it goes to the top and the bottom of the fraction. Negative exponents, so if you have a negative, it basically you take the reciprocal and the exponent becomes positive. So if the exponent is in the denominator, you take the reciprocal, it's now on the top and it's positive. And then zero exponents, anything with a zero exponent is equal to 1. So I'm doing the power of a product property today, or rule today, and every example I do here is going to use that and then use either the multiplication of exponential expressions rule and the power rule. Those are the other rules that are going to be used in addition to this power of product rule. So basically anything involving multiplication I'm covering in this lesson. So we're just going to go at it. We're just going to be simplifying these things. So I've got two examples here on the left and the right. So we've got simplify, and on the left, 5w squared. So we're going to start, we have a product or multiplication inside the parentheses with an exponent or a power on the outside. So this is the power of a product rule we're going to use. So I'm going to write that down. So we're going to use power of a product rule. Actually, I'm going to move this and flatten it out so I don't, if it's flat, I want to aggravate my carpal tunnel. Okay, so now I'm going to be looking down and then looking up. I'm trying. So we distribute the exponent on the outside to the inside. So the 5 is going to get the exponent that is 2. And then the w also gets that exponent of 2. So we get 5 squared w squared. And then we just evaluate. Evaluate basically means do the order of operations. Simplify also sort of stands for that. Basically, when we evaluate, we're just doing the 5 squared. So 5 squared is 25. So our answer is going to be 25w squared. So the power of a product rule, not so bad. I mean, it's pretty straightforward there. And then an example on the right, I've got w, x, y, and the whole thing is to the 6th power. So we've got 3 things multiplied in the parentheses, but the rule is the same. We're still going to use that power of a product rule. So I'm going to again write that down. Actually, I'm going to turn off this light, see if this light's a little... No, that's not any better. Sorry, my lighting is not the best in here. Just the angle is not quite, nope, that's not really helping any, and you just see my closet. So So we're going to distribute our exponent here. So the w is going to have an exponent of 6. The x has an exponent of 6, and y has an exponent of 6. Now these are variables, so we can't actually do anything with them, so that's your answer. That's all we can do here. Pretty straightforward. Okay, now I'm gonna kick it up a notch using some negatives because negatives always throw people off when they're exponents. So I have a negative 3a, and then that whole thing, that whole quantity is to the 4th power. So again, we're going to use our power of a product rule. And we'll just abbreviate power of a product and just abbreviate that way. So we're going to distribute, so the negative 3 has an exponent of 4. So that negative goes with the 3. And then the a gets an exponent of 4. Now notice I put parentheses around the negative 3. Whenever you deal with negatives and you're going to have to do any multiplication or powers or exponents with negatives, always put them in parentheses. This is just to make sure that your negative is included, because if you don't put it in parentheses and then you put this in your calculator, you're going to get the wrong answer. So even with adding or subtracting, sometimes it's just good practice to always use parentheses around them, just so you have it clear. This is a negative, this negative goes with this number. So our rule with exponents is if you have a negative number to an even exponent, your answer will be positive. A negative number to an odd exponent is going to be negative. Think of it as, let's say if we have a negative times a negative, that's a positive. There are 2 negatives there. That would be like an even, like multiplying 2 things together, an exponent of 2. A negative times a positive is a negative. There's 1 exponent, that would be like an exponent of 1. And if you follow the pattern, a negative times a negative times a negative, we have 3 negatives. 2 of them make it positive, and then the third one makes a negative again. So that's an odd, would be equivalent to an odd exponent. So you need to know whether a number is even or odd, and then that can tell you if you're going to get a negative or positive out. So here we have an even exponent of 4, so our answer is going to be positive. You can also make sure that you put it in your calculator. Just make sure when you do that you put your parentheses in there before you do your exponent. So let's see if you can see this. Notice, oh, there we go. I have parentheses around the negative 3 to the 4. So those are really important. Again, that's why we need to write them there. Because if you don't put those parentheses, you're going to get a negative answer. We're supposed to get a positive. So that's why we want to know our rules. So this gives me a positive 81. So our answer here is going to be 81a to the 4th. So same thing here on the right. We're going to start, we have a series of things multiplied together to an exponent. So we're going to use the power of a product rule. And so that negative 3 is now getting an exponent of 3. A is getting an exponent of 3. B is getting an exponent of 3. And C is getting an exponent of 3. Now the negative 3, this is going to be an odd exponent, so because 3 is odd. So the negative 3 to the 3rd power is going to end up being negative. And I could put that in my calculator. Again, I will show it. Make sure you have your parentheses there. And when you hit enter, we're going to get a negative answer out, negative 27. Because a negative times a negative times a negative, 2 cancel out, you're left with a 3rd negative number. So we're going to have negative 27, then a to the 3rd, b to the 3rd, c to the 3rd. So these problems are kind of boring. We're just using the power of product rule. It's pretty simple. You don't really have to do much. It's when we start combining this rule with other rules that it starts to get more complicated. So now I'm going to start throwing in other rules here. we're going to throw in the power of a power rule, or, well, that's what I call it because it's the power of a power, but it's just the power rule is how the textbook calls it, but I call it the power of a power because you literally have a power or exponent to another exponent versus power of a product. Abbreviation that might get confusing, so we'll stick with the book's terminology calling it the power rule. So my first example here on the left, I've got in parentheses 3a to the 5th b squared to the 6th power. So first you use the power of a product rule. And you're going to notice as you do more of these that you always use the same rules over and over again. So we're going to do power of a product rule. So the 3 is going to have the 6th power. And because it's a positive number, I don't need the parentheses there. Then here I am going to put parentheses around a to the 5th in order to indicate that that whole thing is getting the exponent of 6. Because otherwise, if you don't do that there, it looks confusing. And are you saying a to the 56? So if you have something with an exponent already and then you have to put another exponent on it, always use parentheses. So I'm going to do the same thing with the b squared, which is going to get another exponent from that 6 that's on the outside. So that's the power of a product rule. Next step is we're going to use the power rule where you multiply those exponents. And I'm going to wait on evaluating 3 to the 6th. So next we're going to do the power rule because I want to do one rule at a time so you can kind of see what we're doing. So the power rule is when you multiply exponents together, when you have an exponent on top of another exponent on top of another exponent, and things like that. So I'm waiting on the 3 to the 6th. Now I'm multiplying here. So for the a, it's going to be 5 times 6, which is 30. So that's going to be a to the 30 as the new exponent. And then b, we're going to multiply 2 times 6, which is 12. And then after we do that, now we're going to do 3 to the 6th, which I have to do my calculator because I don't have that one memorized. 729. So that's going to be 729 a to the 30, b to the 12. So basically what we're doing here is we're just adding one additional step so that you can see we use the power of a product rule and then the power rule. Now the example on the right, I'm throwing in a little kink here. We've got 18 and then in parentheses u to the 3rd, v to the 4th, and then that whole thing to the 2nd. So we're going to use again the power of a product rule. And I'm going to write it out this time because I don't want it to get confused with the power rule. So, very confusing terminology. So, this exponent of 2 only goes what's inside the parentheses. So, the 18 is outside. It doesn't get that exponent. The exponent only applies to what is inside. So, you want to be very careful about that. So, the u to the 3rd is now getting another exponent of 2. And then v to the 4th is getting the exponent of 2. So that 18 didn't get anything because it's not in the parentheses. That exponent is not attached to that. Next is the power rule. We're going to multiply those exponents. So 18 stays the same. Then we have 3 times 2, which is 6. So u is now going to get a 6. And then v, 4 times 2 is 8. So v is now going to get an 8. Now I always write my u's with a little curve. You can see I write it with that line. I don't do that when I'm normally writing with my regular handwriting. Like I didn't do it in the word product. But whenever I write variables, I do that just so that it looks very different from a v, because I don't want it to get confused. So you may notice that the letters I write when I write variables look different than the letters I write when I write with my normal handwriting. And that's because I'm trying to be very careful to make sure my numbers and my letters don't get confused. It's really important because if you start getting those things confused, it can throw off your whole problem. So this is my last one here, last two problems here. One on the left, it looks simple enough, but it does have that negative, and this time there's not a number there. So I wanted to do something with that. And then on the right, we're now going to be implementing multiple rules here. We're going to also add in that multiplication rule. So we'll start with on the left. If you have a negative there and there's no number and it's with a negative in front of a variable, you can always write that and put a 1 there. It's an assumed 1 or invisible 1, but you can write a 1 there because 1 times k is the same as k. So we're just multiplying it by a 1. That doesn't really change anything. So when you see a negative with a variable, sometimes it's very helpful to do that because once you do that, now you see what you do with that negative with that exponent. So we're going to use the power of product rule, which would help if I actually spelled that right. Too many letters. So the negative 1 is going to have an exponent of 3. And then k to the 6th has an exponent of 3. So I'm going to wait on the negative 1 to the 3rd because I'm going to use the power rule next. So I'm going to just write that down. And so that means we're going to be multiplying our exponents together. So I have negative 1 to the 3rd and then k to the 18th because 6 times 3 is 18. Now I want to evaluate negative 1 to the 3rd. So 1 times 1 times 1 times 1, no matter how many times you multiply by 1, it's going to be 1. So basically this is just going to give us either a positive or a negative 1. So negative to an odd exponent is going to be negative. So we're going to get a negative out. And we usually don't even write the number. We just write the sign. And so this would be a negative k to the 18. So that little trick there is that negative 1 thing. That's why I saved this one to the end, because I didn't want to get too confusing in the beginning. Make sure you understand those rules. So now on the right here, I've got a complicated thing going on, but the first thing we do in a problem like this is the power of a product rule. So that's what we're going to do. Why is that not ready? Let's try this again. There we go. Power of a product. And we need to be very careful because we have two different powers of a product going on because we have two different exponents on top of exponents. Now they both happen to be an exponent of 2, but I like to just draw it in. Basically, this exponent of 2 is going on to these things on that one, and then this one is going to these. So maybe what I'll do is just do 2 different colors to keep those separate. So let me erase those. Now it looks messy. We've got the 4, which is going to get an exponent of 2. We have our c cubed, which now has an exponent of 2, and then d to the 5th, which has an exponent of 2. Let me fix my 5. Okay, now I'm going to switch, and now let's do the next part. We have 3 to an exponent of 2, c to an exponent of 2, and then we have d cubed to an exponent of 2. So we used twice the power of a product rule because we had 2 separate instances where we need that. And so I just did those in 2 different colors to kind of keep those separate just so you can see that. Next step is the power rule. So you notice we're using the same rules in the same order over and over and over again. So I'm going to try to keep my colors again. I have 4 squared. Then I multiply on the c. 3 times 2 is 6, so that's 6c to the 6th. On the d, 5 times 2 is 10. Then I have 3 squared, c squared, and then 3 times 2 is 6, so that's going to be d to the 6th. Now at this point, it's usually helpful for people to rearrange what they have. And actually, let's rearrange. So I'm going to put all the numbers first. I'm going to put them in parentheses so you can see how I'm grouping things together. And what I'm using here is the commutative property of multiplication. So I have 4 squared and 3 squared that I'm grouping together. Then I'm going to group together the c's. C to the 6th, c squared, and then d to the 10th, d to the 6th. So I've just rearranged everything using that commutative property, which says that you can do that. And then I also use the associative property by basically putting them in parentheses, because that one's all about grouping. So associative property, commutative property. Next step here, it doesn't really matter what we do next, but I think we're going to do an exponent. We're going to do the multiplication of exponential expressions. This is how I abbreviate it, because basically they start with the same thing. So basically the c's and the d's, when you multiply things like that, you add the exponents. So I'm going to just leave my 4 squared, 3 squared the same here. Then 6 plus 2 is 8, so I'm going to get c to the 8, and then 10 plus 6 is 16, so that's going to be d to the 16. Now I'm actually going to do the multiplication for the number parts. So 4 squared is 16, 3 squared is 9. Now I actually am running out of room here. Okay, I'm going to trying to squeeze these in. Sorry about this. I thought I would have enough room. I'm going to have to write really small here. Downside of only having a slide. So that's 16 times 9. And so 4 squared is 16, 3 squared is 9. So 16 times 9 is 144. So our final answer will be 144, c to the 8, d to the 16. And there we go. So barely enough room there. I might have to, in the future, try to move up my line with the problems. But we always start here with problems like this. We do the power of a product. Then we do the power rule. If there's no power rule, you just skip that. Then you do any multiplication if you need to, and then you evaluate. If there's no multiplication, you go straight to the evaluating. So you'll skip steps as you need to, but you can see how we do the same order essentially every time. And it's the same thing with the quotient rule. You kind of do the same order. It's just instead of you usually will, with the quotient, you usually end up doing that, and then you have a quotient rule, or you might have to start combining these and you have to do them in certain orders. I usually recommend that when you're simplifying exponents, you're doing them in the same sort of order as the order of operations. So if there's things in parentheses to simplify first, do that. And then you do any exponents, which means the power of a product rule. Once you have all of that taken care of, then you've got your multiplication and division. And again, that goes left to right. In the case of if you have fractions, it's usually top and bottom are grouped together. Then you do any addition and subtraction last, which would be basically when you're adding the exponents. So you can think of the exponents sort of following those same rules, the same order of operations. It just looks very differently, and it's just a matter of knowing the rules and knowing, okay, these are applying to exponents, this is applying to numbers. And you want to be very careful not to get your number rules confused with your exponent rules, because If you have 4 squared, we're not multiplying those exponents. That's 4 to the second power. It's different from a to the 4th to the second. So sometimes people just get on a roll and they just start multiplying everything together, and instead of doing 4 squared, which is 16, they write 8 because 4 times 2 is 8. I've actually done that. So you want to be very careful, make sure you slow down. And that's one reason why I save my number stuff for the very end, so that I can make sure if I don't do it at the same step as other things, I'm less likely to do the wrong roll, if that makes any sense. So those were all the examples that I had on power of a product. Hopefully people watch this video afterwards, so it's not just made for no reason. So hopefully I'll see you guys next week and you found this helpful. So bye.